So I want you to picture a book. It's sitting in a vault at Yale,
Right, at the Beinecke Library.
and it's about 600 years old. Looks pretty normal. It's bound in vellum, modest size.
It looks like a standard medieval field guide, but then you open it.
And that's when it gets weird. You aren't looking at history. You're looking at, what can you even call it? A fever dream.
It's called the Mount Everest of cryptography, the Voynich Manuscript.
And you see these drawings of plants, star charts, all sorts of things.
But the plants, well, they don't exist. Not on Earth, anyway. The zodiac wheels are all wrong. And then there's the text.
Ah, the text. It's this beautiful looping script. It looks like a real language. Someone who knew what they were doing wrote this.
A very steady hand. Yet here we are, centuries later, and nobody can read a single word.
Not the codebreakers who cracked Enigma, not alchemists, and not even our most advanced AI.
For the longest time, the attitude was just, oh, we have supercomputers now. We'll solve it.
That arrogance.
Exactly. And that's really what we're diving into today.
We've got a whole stack of new research from late 2025, early 2026 that just turns that whole idea on its head.
We've got a theory that it's a medieval zip file, another that it's based on a card game, and a big reality check on why AI keeps, well, hallucinating when it looks at it.
So that's the big question, right? Can modern tech finally crack this thing, or have we just built machines that tell us what we want to hear? These fluent lies.
That is the central tension.
Okay, let's start there. With the AI, because I think most of us assume, you just feed the data in, crunch the numbers, and out pops a translation.
Right. Why hasn't that happened?
Yeah, why not?
It comes down to a basic misunderstanding of what these large language models, these LLMs, actually do. They're not truth machines.
Probability engines.
They're probability engines. They're pattern matchers. If I say peanut butter and...
jelly.
Right. The AI will scream, jelly, because that's the most statistically likely next word. Now, imagine feeding it a string of letters from the Voynich Manuscript. The AI doesn't see nonsense. It sees a puzzle. It has to find a pattern.
So it's not translating. It's forcing the chaos to look like something it recognizes.
It's digital pareidolia, like seeing a face in the clouds. The AI sees a language in the scribble because it's been trained on millions of languages.
There's that big study, right? The one from the University of Alberta.
The Hebrew debacle. Yes, that's the perfect example of this trap.
They fed it into the AI, and it came back, saying, I've got it. It's medieval Hebrew.
That was the big claim, but with a huge catch. The AI decided the vowels were missing and all the letters were scrambled into anagrams.
Which is already a big assumption.
A massive one. So the researchers took this jumble of consonants. The AI spat out. They kind of manually massaged it into something that looked like words. And then, and this is the killer mistake, they fed it into Google Translate.
Oh, no. And Google Translate always wants to be helpful. It never wants to say, this is just garbage.
It will do anything to give you a coherent sentence.
Yeah.
So from this chaotic soup of data, it produces a perfect English sentence.
Which was?
She made recommendations to the priest, man of the house, and me, and people.
Okay, that sounds like a translation.
It sounds great until you look at the actual page in the book that it supposedly came from.
That one's on the page.
Herbal drawings,
I do it.
botanical recipes,
Yeah.
star charts. There are no priests, no women giving advice, no houses.
The sentence is completely disconnected from the illustrations.
Zero connection. It's a fluent lie. It looks right, it sounds right, but it's pure fiction.
And the consensus in the cryptography community now is basically that AI is useless for this.
For now, yes, because we have zero confirmed training data for Voyniches. Without a Rosetta Stone, any translation an AI gives you is just a hallucination. It's guessing.
So, okay, brute force AI is out. It's
Yeah.
just mapping the manuscript onto languages it already knows.
It's hitting a wall.
But that leads us to this fascinating new theory from January 2026, Michael Greshko. And this one suggests we're failing because we're looking for a language, when maybe we should be looking for a game.
This is the Naive cipher hypothesis. And I love this one because it steps away from all the high-tech stuff and goes right back to the 15th century, to a gambler's pocket, basically.
It's based on a card game.
An old medieval Italian card game called Naive. The theory says this isn't a simple substitution cipher, where A always equals B.
Right, the classic code-breaking 101. You count the symbols.
Exactly, frequency analysis. But this theory says the system was stochastic. It involved randomness.
Like rolling dice.
Precisely.
Right.
Imagine you want to write the letter E, which is super common. But before you write it down, you draw a card or roll a die.
Okay.
If you roll a 1 or a 2, maybe you write a star symbol for E. But if you roll a 3 or 4, you write a triangle. Roll a 5 or 6, you write a circle.
Whoa. So the letter E could be 3 different symbols just depending on luck.
Exactly. And it could work the other way, too. Different letters could map to the same symbol depending on the roll. It creates a one-to-many mapping.
So you can't count the symbols to crack it.
You can't. It totally destroys the statistical fingerprint of the underlying language. The symbols become shifting shadows of the real letters.
That is diabolical.
It's incredibly effective. And what Greshko found was that when you apply this card game mechanic to normal Italian text, the output looks stunningly like Voynich.
It matches the weirdness, the word lengths and all that.
All of it. The symbol frequencies, the structure. It proves you could create this text with 15th century technology. No aliens, no lost civilizations needed.
Just a very clever scribe with a deck of cards who basically created a puzzle that's impossible to reverse without knowing the exact sequence of card draws.
He created a one-way hash centuries before we had a name for it. The meaning is in there somewhere, but it's shattered into probabilistic pieces.
Okay, so that theory implies the author was actively trying to hide the meaning, to make it unreadable. But there's a whole other camp that thinks the exact opposite. That the author wasn't trying to hide anything, they were trying to save space.
And this is where it gets really strange. This is the medieval zip file hypothesis.
This is the one that suggests the author was like a time-traveling data compression expert.
It sounds wild, I know. It comes from a preprint paper by Jaba Tmaladze, but when you look at the evidence in the text, it starts to make a weird kind of sense.
Okay, convince me. A guy with a quill and ink inventing a ZIP file 500 years early, that feels like a stretch.
It does sound anachronistic, but just look at the manuscript. Have you noticed how repetitive some of the words are?
Wow.
You'll see things like quokey, then quokety, all in a row.
Yeah, it looks like stuttering, like a typo.
And linguists hate that because natural language on paper doesn't work that way. We don't write the dog, the doggy, the doggledy, but you know what does look like that?
Computer code.
Compressed data, specifically an algorithm called LZ77, which is the foundation for modern ZIP files.
So those repetitive words aren't actually words.
The theory is they're back references.
What does that even mean in a handwritten book?
It means instead of writing out a long word over and over, the scribe writes a short code that basically says, hey, copy the word I just wrote, but change the ending.
So quokey doesn't mean flower or whatever. It means repeat the last thing I wrote, swap out the last letter for a Y.
You got it. And if that's true, the text looks bizarre to us because we're trying to read the compression instructions as if they're the content itself.
We're reading the code, not the document.
Exactly. And that would explain another huge mystery. The text has incredibly low redundancy. In English, if I write TH, you can guess the next letter is probably E.
There's a predictability to it.
A huge amount. The Voynich text strips all that away. And that's precisely what happens when you compress a file. You remove the predictable redundant bits to make it smaller.
So maybe the goal wasn't secrecy, it was just to save money on vellum.
Vellum was unbelievably expensive. If you could figure out a shorthand to fit a whole library into one book, that would be revolutionary. But of course, without the unzip manual, to us it just looks like gibberish.
Which brings us to the big skeptical question. Are we just overthinking all of this? Could it just be an elaborate hoax? Gibberish sold to some emperor for a pile of gold.
The hoax hypothesis. It's the elephant in every room when you talk about the Voynich. But the math, the deep statistical analysis, argues pretty strongly against it.
How so?
Well, there are a few tests, but a big one comes from a study by Layfield and Amancio. They looked at something called the uniqueness point.
Okay, let's break that down. The uniqueness point.
It's the exact moment in a word where it can't be mistaken for any other word.
Sure.
So in English, if I say aleph, it could be elephant or elephantine.
Elephicasis, yeah.
Right, but the moment I say elephant, you know what the word is. That T is the uniqueness point.
It's the point of no return.
It is, and in every natural language, the position of that point follows a very specific statistical pattern. And Layfield's study found that Voynich follows that pattern perfectly.
And if you were just making up words, just writing random scribbles.
Yeah.
You wouldn't accidentally create that pattern.
The odds are astronomical. Hoaxes and random text almost always fail these deep structural tests. They're either too random or too repetitive in the wrong ways. The Voynich manuscript behaves, mathematically, like it has real grammar and syntax under the hood.
The math says it's real.
The math says it's real.
So we've got AI saying it's Hebrew, a historian saying it's a card game, a data scientist saying it's a zip file, and statisticians saying it's definitely a language.
Right.
Why is there no consensus on even the most basic things?
Because you can't even agree on the alphabet.
Wait, what? We've had the book for over a century. We don't know what the letters are.
This is the problem the Bernasconi paper highlights. They use these advanced AI vision systems, convolutional neural networks, just to identify the individual symbols. And the computer struggles. The script is so fluid, it's so cursive, letters are joined together constantly. Is that symbol one letter, or is it two letters linked together?
Like an O and an L becoming one shape.
Exactly. The AI identified about 26 distinct clusters of shapes, which sounds like an alphabet, but it couldn't consistently tell them apart because the handwriting is so variable. We're trying to decrypt a message when we're not even 100% sure what the characters are.
We're building theories on a foundation of slush. It feels like we just keep projecting our own time onto this book.
That's a great way to put it.
In the 1500s, they thought it was alchemy. The Cold War codebreakers thought it was a military cipher. Now in 2026, we think it's a zip file.
We see what we know, we use the tools we have, and honestly, that might be the most important lesson the Voynich manuscript has to teach us, even if we never translate a single word.
What do you mean by that?
I think the big so what here is that this book is a firewall. It's a firewall against our modern technological arrogance.
We think our computers can solve anything.
We have these incredible LLMs, these neural nets, and we assume that if you just throw enough processing power at a problem, the answer will pop out.
But it can't solve for context. It can't solve for culture.
It cannot replace human understanding. The manuscript proves it. Without knowing the rules of that card game or the specific compression shorthand the author invented, the math is useless. All the AI can do is hallucinate an answer to make us happy.
That's a pretty sobering thought, especially when we're using these same AI tools to summarize medical reports or write legal arguments.
And if an AI can look at a book we know is unreadable and confidently tell us it's a Hebrew text about a priest, how many other fluent lies is it telling us that we just haven't caught yet?
Because we don't have the original unreadable book to check its work against.
Precisely. We only catch the lie here because we know the Voynich is unsolved. It's the control in the experiment. The manuscript is the only thing honest enough to prove that the machine is lying to us.
That is a little terrifying.
Yeah.
A 600-year-old reality check.
It is. And it should force us all to stop trusting the output just because it looks polished and sounds confident.
Well, on that note, I think I'd just encourage everyone listening to go look at the manuscript online. Yale has it all digitized. Don't let an AI tell you what's there.
Yeah, look with your own eyes.
Maybe you'll see something the algorithm missed. Maybe you'll see the card game or the zip file, or maybe you'll just see the beautiful, unreadable mystery of it all.
And hey, if you crack it,
Oh, please let us know.
definitely let us know.
That's our deep dive for today. Thanks for listening.